In this video, we're going to talk about a frequently used identity of the Levi-Civita simple, that is epsilon ijk epsilon rsk is equal to Kronecker delta, the first indices ir, Kronecker delta second indices js, minus Kronecker delta jr inner indices and Kronecker delta is. So let's prove this. Now, what is the meaning of epsilon ijk epsilon rsk? Einstein's summation notation tells me that we have to sum over the repeated index k. So this means it is epsilon ij1 epsilon rs1 plus epsilon ij2 epsilon rs2 plus epsilon ij3 and epsilon rs3. Okay, so let's consider the cases when epsilon ij1 and epsilon rs1 are not equal to 0. This will be the case if I is not equal to 1, j is not equal to 1, r is not equal to 1, s is not equal to 1, I is not equal to j, and r is not equal to s. So then I'm considering the non-zero cases. Okay. Now, let's see. If I is equal to 2, j is equal to 3, r is equal to 2, s is equal to 3. 2, 3, 1, 2, 3, 1. 2, 3, 1. So 1, 2, 3. 2, 3, 1 is the positive direction. So that gives me plus 1 times plus 1. The answer is going to be plus 1. If I do 3, 2, 3, 2, 3, 2, 1, 3, 2, 1, 3, 2, 1 is minus 1, 3, 2, 1 is minus 1, minus 1 times minus 1 will give me a plus 1. And if I is equal to 3, j is equal to 2, then I have 3, 2, 1. And if r is equal to 2 and s is equal to 3, then it is 2, 3, 1. So this is minus 1 times plus 1. It will give me a minus 1. If I is equal to 2, j is equal to 3, 2, 3, 1. 2, 3, 1 gives me a plus 1. But if r is 3 and s is equal to 2, then I have 3, 2, 1, which is a minus 1. So plus 1 times minus 1, that gives me a minus 1. So I've considered the cyclic permutations of 1, 2, 3, and this is the positive direction, I remember. Okay, so I can summarize these results by saying if IJRS values are 2, 3, 2, 3 or 3, 2, 3, 2, I'm getting a plus 1. If they are 2, 3, 3, 2 or 3, 2, 2, 3, I'm getting a minus 1, and otherwise one of these indices will be equal to the other, so I'm going to obtain a 0. Okay, and also you see that when this is plus 1, so when I and j are 2 and 3, 2 and 3 will basically make sure that I have a repeated index here. This is 0, and 2 and 3, having 2 and 3 here, also will have a repeated index of 3 here, so that's going to be 0. So this is going to give me plus 1 when I have this scenario for the indices. Okay, likewise, if I look at epsilon ij2, epsilon rs2, when I and j are 3 and 1, r and s are 3 and 1, 3 and 1, so this is going to be 3, 1, 2, 3, 1, 2, which is positive. So this is plus 1 times plus 1. It will give me a plus 1. And if it's 1, 3, 3, 1 or 3, 1, 1, 3, it is minus 1 and 0 otherwise. And when I and j take these values, 3 and 1 or 1 and 3, which means these terms will give me 0, and this is the only one that will give me a non-zero answer, either plus 1 or minus 1. And for epsilon ij3, epsilon rs3 term, I can have 1 or 2 for each of these indices. So this 1, 2, 1, 2 scenario, 1, 2, 3, 1, 2, 3, gives me plus 1 times plus 1, plus 1. Or if I have 1, 2, 2, 1, then it's going to be plus 1 times minus 1, or minus 1 times plus 1 if it is 2, 1, 1, 2. This will give me a minus 1, and it is 0 otherwise. So you can see, if I pick any of these scenarios, for example, let's pick this scenario, 1, 2, 3, 1, 2, 3. So that means this term will give me plus 1 times plus 1, plus 1. 1, 2, 3, 2 is repeated, so epsilons will give me 0. 1, 2, 3, 1 is repeated, this is going to give me 0. So the answer will be plus 1 in that case. Okay, so this implies that epsilon ijk, epsilon rsk is equal to plus 1 when I is not equal to j and r is not equal to s, and I is equal to r, I is equal to r, and j is equal to s. I is equal to r, j is equal to s. This means I have a Kronecker delta here. I must be equal to r, j must be equal to s. And if I is equal to s, then I have is, Kronecker delta is. And here I have Kronecker delta jr. And that's this scenario. I is equal to s, j is equal to r, inners and outers. That gives me a minus 1. And it's going to be 0 otherwise. Okay, so this result can be written as the plus 1 happens when I have the product of Kronecker delta IR, Kronecker delta JS, and minus 1 for Kronecker delta IS, Kronecker delta JR. So this is going to be equal to plus 1 if I is not equal to j, r is not equal to s, j is equal to s, and I is equal to r. So j is equal to s, I is equal to r. This gives me plus 1, and this is going to give me 0. And j is equal to r, and I is equal to s. This is going to give me a 1 here, so minus 1. But this part will give me 0, so that's a minus 1, and 0 otherwise. So you can really see that this product, epsilon ijk, epsilon rsk, is Kronecker delta IR, first indices, Kronecker delta JS, second indices, minus Kronecker delta JR, inner indices, Kronecker delta IS, outer indices. So firsts and seconds, inners and outers. So minus inners and outers. So that's how we see this Levi-Civita identity. So once again, we must have a repeated index. The repeated index must be in the same location, the last location on the epsilon. So the third position here. And once that's established, this product will give us Kronecker delta first indices, Kronecker delta second indices, minus Kronecker delta inner indices, Kronecker delta outer indices. So that's the Levi-Civita identity.